In this section, we will explore the basic structure of an atom. An atom can be described as the basic building block of matter, which is the stuff that makes up everything around us. Atoms are tiny particles that cannot be seen with the naked eye. Imagine Legos for the universe, but way, way smaller. Atoms come together in specific ways to form all the different materials we see, from a grain of sand to a battery electric vehicle. Electricity revolves around the movement of electrons within atoms. Knowing how these tiny charged particles behave is essential for understanding electrical circuits. Atoms consist of three main components. They are protons, neutrons, and electrons. This structure of an atom consists of protons and neutrons, surrounded by electrons in orbit around the nucleus. Protons are the positively charged particles that make up part of the nucleus, which is in the center of the atom. Neutrons are the uncharged particles that make up the other part of the nucleus. Electrons are the negatively charged particles that orbit around the nucleus, like the planets orbiting the sun in our solar system. The structure of an atom is related to electricity in two ways: electron movement and electron placement. Electron movement is the current. Electricity is all about the flow of electric current. This current is created by the movement of electrons from one atom to another. Imagine tiny charged balls, electrons, flowing through a wire like water in a pipe. In electron placement, the number of electrons in an atom's outer shell, also known as the valence shell, and how tightly they are bound determine how well a material conducts electricity. Metals, for example, have loosely bound outer shell electrons that can move easily, making them good conductors. In contrast, materials like rubber have tightly bound electrons and resist this flow, making them insulators. So, the structure of the atom, particularly the arrangement and behavior of electrons, dictates how electricity interacts with different materials and ultimately creates the flow of current. Imagine the atom like an onion, with layers called electron shells surrounding the nucleus. Each shell holds a specific number of electrons. The outermost shell, called the valence shell, is the most important. This shell is important as it determines the substance's conductivity, insulation properties, or potential as a semiconductor. The number of electrons in the valence shell determines whether a material is a conductor, easily conducts electricity, insulator, resists electricity flow, or semiconductor, acts as both conductor and insulator under certain conditions. Understanding the valence shell is a practical tool to predict how different materials will behave with electricity. An electrical charge is the electrical characteristic of matter caused by its deficiency or excess electrons. This charge disparity manifests in treating behaviors and interactions in the realm of electricity. Therefore, electrons have a negative charge, while protons, in the nucleus, have a positive charge. Imagine rubbing a balloon against your hair. As you pull the balloon away, your hair appears to cling to it, displaying an interaction of electrical charges. During this process, the balloon transfers electrons from its valence shell to our hair. Consequently, our hair accumulates in excess of electrons compared to protons, rendering it negatively charged. Having relinquished some electrons, the balloon now possesses a surplus of protons, resulting in a positive charge,